Welcome back. Let's talk Pythagorean Theorem today. This is concept 14. In example 1 here, we're going to talk about the Pythagorean Theorem. The Pythagorean Theorem is one of those things that we've kind of learned it probably 3, 4, 5 times over the course of our math career. But let's review it. The Pythagorean Theorem is a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. Okay, so a and b are the legs, c is the hypotenuse. So we're going to find the value of x, and we're going to give our answer in simplest radical form. What I like to do first is I like to go through and I like to figure out what do I actually have. And so I'm going to label the sides a and b, and we'll notice that because addition property is commutative, it doesn't really matter what order we do them in. And so this x is going to be c because it's opposite the right angle. When I move over here and I do a squared plus b squared equals c squared, what I'm going to notice is I'm going to do 6 squared plus 4 squared equals x squared. So I'm solving for the hypotenuse, which is the unknown. And I'll simplify this into 36 plus 16 equals x squared. And when I go ahead and do this, I'm going to end up with 52 equals x squared. And I'm going to take the square root of both sides. So the square root of 52 equals x. Now I have to determine whether I can take out a radical. And so what I'm going to do is I'm going to make this the square root of 13 times 4, because I know that 4 is a perfect square. And so that'll be the square root of 13 times the square root of 4 equals x. And so my answer is going to be 2 square root of 13 equals x. All right, so that's my simplest radical form for solving for that hypotenuse. Pretty simple, plug it into the formula. The most difficult part sometimes is finding that reduced radical form. Let's do one where they give us an expression as a side. So we're going to find the value of x and give our answers in simplest radical form. Once again, I want to label my sides, so I'll make this side a and b, c, making sure that the hypotenuse is always c. What I'll do is I'll just plug it into my formula now. A squared plus b squared equals c squared. And that's going to be x minus 2 squared, so I'll have to do a little bit of foiling, plus 4 squared equals x squared. Step out to the side here. X minus 2 squared really is equal to x minus 2 times x minus 2. And so I'm going to do the FOIL method, so I'll do the first one, so that's x squared. Outside ones, inside ones, last ones, and I'll end up with x squared minus 4x plus 4. Made a little mistake here. Don't have the equal sign yet. Plus 4. And that's going to go in for my x minus 2 squared. So let's check out and see what we've got. X squared minus 4x plus 4 plus 16, because that's this 4 squared here, equals x squared. Well, what I'm going to do is I'm going to subtract x squared from both sides. And you'll see what happens pretty quickly here. That goes away, that goes away. So I have negative 4x plus 20 equals, and now this is 0 on this side, so I am going to try to make my expression positive, so I'm going to add 4x to both sides. And you'll see that I end up with 20 equals 4x. So I'll end up with x equals 5. And if I plug this back in, you're going to see what happens. So this is 5 minus 2 equals 3 for my side, and 5 would be this side. So it's my 3, 4, 5 right triangle. It's got whole numbers as the sides. This is a good thing. That's really, really easy to check. Here's an example for you. I've got one of each for you, one where there's numbers as the sides and one that has expressions as the side. I'd like for you to try these two on your own. It's good practice. Try those on your own. The next thing we're going to talk about is Pythagorean triples. I've got a little demonstration here for you. So let's take a look at that. So here's a look at how the Pythagorean Theorem app kind of set up. And what it does is it takes this triangle and it measures each of the sides. So here you can see this side is side A, and down here is side B, and side C is going to be the hypotenuse. This is going to remain locked at a 90-degree angle here. And on the side here, I've tried to model the Pythagorean theorem. So I've got a squared plus b squared, and it's going to give me a total. And I've also got c squared, and it's going to give me a total. You'll notice a squared plus b squared equals c squared, because it's a right triangle. So right now it's 5 and 8, and c is 9.43. Well, those are going to be equal. My goal in finding Pythagorean triples is to find whole numbers that satisfy this equation. So for example, a and b right now are whole numbers, but c is not. And so I want to move the vertices around to try to get whole numbers for all three of them. So if I do a little bit of experimenting, and I move this down, I notice my c becomes a little bit closer to a whole number, and then I've got, if I move down to 3, it's a little bit farther away. So maybe I'll try to move b in. And I look, and I'm going to see that now I have 3, 4, and 5. So one Pythagorean theorem, Pythagorean triple, is 3, 4, 5, making sure that we go A, B, C. So 3, 4, and 5. If I move them around a little bit more, and I do a little bit of experimenting, I'm kind of cheating because I know, and I move them around a little bit more, you're going to notice 5, 12, and 13. So 12, 5, and 13 is another Pythagorean triple that I can use. Everything else in between those kind of gives me these decimals. You see that? So I've got these numbers for A and B, and as I move them around, I'm going to notice that my C, sometimes it gets close to a whole number, like there's 13.04, but that's not a whole number. So Pythagorean triples are numbers that go together that satisfy the Pythagorean theorem and are all whole numbers. Okay, so you see how this works. All right, so now that we talked about Pythagorean triples, I'd like for you to find the missing side length and let me know if they are Pythagorean triples. The key is going to be, if they end up as whole numbers, then it's going to be a Pythagorean triple. Let's try the first one together. I'll label my sides again. And C doesn't happen to have an X here, but that's fine. I can just call it C. So I'll do 14 squared plus 48 squared equals C squared. And I don't necessarily need to know what that is, except that I'm going to try to test these. And so let me grab a calculator real quick. Okay, 14 squared is going to give me 196. Maybe some of you out there knew that one as one of your times tables. And 48 squared equals 2304 equals C squared. So I'm going to add to that 196. And I end up with 2500. It's looking pretty good. And so I'll take the square root of both sides. Square root. Answer. And I get 50 is equal to C. Well, let's look at what that gives us. That gives me a whole number, and a whole number. So yes, it's a Pythagorean triple. Okay, I want you to try the next one, see what you get. Take note, when you label these A, B, and C, they've already given you the hypotenuse, so you're going to have to do a little bit of solving in there for one of the side lengths. But that's all right. Thanks for watching, guys, and we'll see you next time.